In this video, I want to introduce one more scheduling scheme. This one's going to be called proportional share scheduling. So the idea is this. You have basically, you pick some interval, right? We say, okay, we're going to schedule over this interval. This interval has something like, 100 blocks, right, of processing power, right? And you could do it out of 100 or maybe do some other number. What basically we're saying is we're going to portion up whatever it is that I have during that interval and give it to different processes. So maybe, right, I have 100 units of so 100 shares is maybe how I divide how much time or effort the CPU can put into different processes. And then what I'll do is I can basically split that up. So I can basically say things like, A will get 30 units, B will get 40 units, C will get 30 units. Something like that, right? So basically we kind of discretize, right, the amount of CPU work, right, we can do, and we split into chunks, right, and give each of those chunks to a different process. So this is what we call proportional share scheduling. And the idea, right, is that if I do something like this, I can basically have, like A, right, basically just gets locked into just using 30, right? B is locked into 40, C 30. And so if I'm doing something like running a process, basically what I can say is this process will ask, I need 30 units of time, right, 30 units. Do I have that available or not, right? And if it does, then I grant it, right? I give that process 30 units that it wants, right? It can run, it can do its stuff, right? And I know it's basically going to get enough CPU. Now, if a process comes along and requests more, it's like, I need 90 units. Well, then all of a sudden, hey, I have already 70 units of something running, right? And picture A and B are there. I just don't have enough space to fit you in, right? In that case, you can basically reject it. So it's kind of nice in terms of, I can know kind of in advance, will I have enough CPU to give to this thing or not, right? Because everybody is basically is obligated to say, this is how much CPU I want, and then I can check to see what's available, and if it is, I grant them those resources, right? And they'll basically hang on to them until they're done. So the question there, right, is basically, would we ever use a schedule like this? So this is actually very typical for like a server environment. So if you have a ton of users attached, basically what happens is you say, okay, this server can support 100 units, 100 users, so I'll basically break its time into 100 different chunks, and every time somebody signs on, that's the equivalent of requesting one chunk or 1 unit of time, right? And then they can basically do whatever they want within that, right? But that's kind of their limit. And I can control, like, I have 60 users, that means there's 60 units available, or 60 units to use, 40 available. That's great, right? If somebody wants to come along, they can jump in there. But if I have 100 blocks, then basically nobody else can be allowed to join in. The final thing I wanted to mention, this is just really brief, is basically how do we activate some of these scheduling schemes inside of Linux. So here, right, basically we have some sample code, and the sample code lets us basically check to see what is the current policy, and then based on the current policy, actually set it. So in this case, right, we can basically, right, we have this kind of attribute set get policy, right? This is something we've seen actually a little bit before. The idea, right, is that process attribute struct, right, that we use thread attribute struct, where we use whenever we create a thread. We want to basically go in there, right, and check to see what is the value of the scheduling policy that's in place, right? So we pass in our attribute, check out what is basically, so this is going to be, there's some variable out here. I should probably add this in. This is policy, right? This basically line here is going to read from the attributes struct, right, find out what the policy is, stored into the policy variable. In that variable, we can check it. There's 3 different schemes. The first one is other. Other really doesn't count. Other is kind of OS specific, right? So if you're on a different kernel or whatever, right, it's basically undefined. So probably don't want to use that. Then we have kind of our typical ones, right? So we have round robin scheduling if you want to enable it. First in, first out, right, or first come, first serve. That's our other choice, right? So we can kind of go between those two. There's not a lot of flexibility there, but it's what we get, so. Last bit here is basically a set the schedule policy. So here, right, we can do basically our set schedule policy, right? And this case right here, we're saying to first in, first out. Okay, so not too bad. So if you want to, right, it's maybe, it's going to be hard for you to know what to pick here, right? Generally, you just want to leave it to the operating system. But if you did want to enforce something, if you did want to enforce round robin, if you did want to enforce first come, first serve, this is how you do it.